Hello dear students, today we will discuss about the past paper based on AS level. There are 40 questions. In this video I will discuss 15 questions so I can check how much you will enjoy this video. After this video I will upload another one to complete all the questions one by one. You know, all the questions are actually multiple choice questions. So the first question is, which unit is a SI base unit? You know that there are two systems, SI unit system and CGS unit system. But he is asking about SI base unit. There are four physical quantities, 4 units: ampere, coulomb, degree Celsius and gram. You know that coulomb is actually the unit of charge and degree Celsius is actually the unit of temperature and gram is the unit of mass. But ampere is actually the unit of current. And you know that there are 7 physical quantities, fundamental physical quantities. Among all the 7 physical quantities, there is only one physical quantity, that is current, which is having the unit ampere, and all the others are not the fundamental physical quantities. So the correct answer is ampere. This is called the SI base unit, because you know that if there is current, we can measure it in amperes. If there is a temperature, we can measure it in Kelvin. But there is not any Kelvin. If there will be a Kelvin, that I can choose that option also. But there is not any such type of fundamental physical quantity. And if we are talking about mass, mass is also having the unit that is in kg. So kg is actually the base unit. I hope you understand it very well. Now I will go towards the next question. Next question is, which of the following could have the same units as force? There are four options. That is energy divided by distance, energy divided by time, momentum multiplied by distance, momentum multiplied by time. If you will check, there is energy divided by distance. So energy divided by distance is the only option which gives us the same unit as force. That is, you know that force is a unit that is Newton. So energy divided by distance is also equal to Newton. You know that work is actually equal to force multiplied by distance. So force is Newton. Displacement is actually measured in meters, so it is in Newton meter. But work is having the unit that is joule. If we will divide this work, that means joule, energy divided by distance, that is meter. So joule divided by meter, we will divide on right side also meter. This meter and meter gets cancelled, that is equal to the Newton. I hope you understand it very well. So energy, if we are discussing about energy, that means the same thing we are discussing about actually the work done. Work done is also measured in joules. So if we are discussing this, that is energy is actually work divided by meter. This is distance and it is unit. Work unit is actually joule divided by distance, that is meter. So joule divided by meter is also known as Newton. How? Because joule is work, but work is equal to force multiplied by distance, that is distance unit is meter, and here is also meter. This meter and meter gets cancelled, so it is force, that is unit is Newton. That means there is only one option, that is energy divided by distance, which is having the same unit as force. Now there is third question. Third question is here, the velocity of an object changes from an initial velocity u to final velocity v. The vectors represent these velocities. Two velocities are represented. This u is known as initial velocity. This is known as initial velocity. And this one is known as final velocity. You know it very well. Direction is important. Suppose I will draw here a draw here both the vectors, that is u, and this one is having like this direction, that is v. Can we take this vector, this v vector, at this place? If I will take at this place by using the triangle law, so this is also v. Now you know that where will be the resultant? Resultant will be like this. And just check it. This is u and this is in the downward direction, that is minus v. So resultant will be u minus v. U minus v. And just check it now. This resultant is actually in this direction. So which option is correct? The correct option is C. So it is same direction to that of this one. If I will show you here, let us consider there are two vectors like this. This is u and this one is v. Resultant will be like this. But you know that if this is a v, I will take this v at this place. So resultant will be u plus v. Because v is in the upward direction. Upward direction will take positive, but downward direction we are taking here negative. So resultant will be in the downward direction like this, but its value is u minus v. Suppose if there are two vectors like this vector is in this direction and another vector is in this direction. So I will take the resultant like this. What will be the resultant? You know that resultant, if all the vectors, suppose resultant will be this one. This will be the resultant. But if all the vectors like this, if this is the first one vector, another one is like this, and after this there is like this, there is a zero resultant. At the place of resultant, you must remember there is both the tips combined. These tips are combined. You know that there are if there is a vector, this one is called a head and this is called a tail. At the resultant, these two heads are combined. Just check it in zero resultant. This one, is there anywhere two heads are combined? No. So that we can say the resultant will be zero. I hope you understand it very well. Now there is fourth question. An object is moving with a initial velocity u. The object then moves with uniform acceleration a for time t until it reaches final velocity v. I think we have discussed it so many times. There are actually three equations of motion. V is equal to u plus at. Second equation is equal to s is equal to ut plus 1/2 of at square. And third one is equal to 2as equal to v square minus u square. So you check it. The object then moves with a uniform acceleration a and time is t. So which equation is correct? This is the correct equation, that is having initial velocity, final velocity, acceleration constant, time. This equation is also known as velocity time relation. Velocity time relation. Is there any option which is same to that of this option, this one, v is equal to u plus at? Yes. Just check it, v. There is written as u equal to v minus at, but we can write it v equal to u plus at. The examiner just changes u and v. He makes the subject as u, and we are generally taking v as subject. I hope you understand it very well. Next question is, which calculation produces a vector quantity? Current and time. These are the two. Current multiplied by time. And next one option is final displacement minus initial displacement. You know that. It is very easy. Displacement is the vector quantity. Current and time, no, it's a scalar. Work done divided by time, no, it's scalar. 1 divided by 2 mass into velocity square, that is, you know, this is a kinetic energy. This is also scalar quantity. This one is scalar quantity. So only option is, that is final displacement minus initial displacement. Final displacement means maybe it is 5 meter and initial displacement will be 3 meter. Let us consider. So if we will subtract both, we get again displacement. Displacement minus displacement is a displacement. So these are actually the quantities. So the correct option is, which one is the correct option? That is B is the correct option. Now there is another question. A thermometer can read to an accuracy of plus minus 0.5 degree. Plus minus 0.5 degree. This thermometer is used to measure a temperature rises from 40 to 100 degree. So what is the difference? Difference is 100 minus 40. That is 60 degree. And he says, what is the percentage uncertainty in the measurement of temperature scale? First of all, we will find the total absolute percentage. How much is total absolute percentage? Total absolute percentage is plus 0.5 plus 0.5. That is 1 degree. And now he is actually asking percentage uncertainty. Percentage uncertainty is a definite formula. There is a definite formula that is known as percentage uncertainty. Uncertainty is always equal to absolute uncertainty divided by measured value. Just check it now. It is very easy. Now absolute percentage, absolute uncertainty. Absolute uncertainty is 1 divided by measured value, that is 60, multiplied by 100. You know, we are discussing about percentage, so we definitely will multiply 100. This will be, I think, 10 divided by 6. That is 1.66. Approximately this value is equal to 1.7%. You understand it very well. I hope you understand it very well. Now there is another question, that is, the diagram shows the path of a golf ball, which row describes change in the horizontal and vertical components of the golf ball's velocity when air resistance is ignored. There are 4 options: horizontal and vertical. You know that when there is a projectile motion, there are 2 types of motions. One is known as horizontal motion. Another one is known as vertical motion. Horizontal motion shows constant velocity. There is a constant velocity. We will discuss it. The horizontal component of the velocity remains the same throughout this journey. The horizontal component remains same throughout the journey. Now there is another component, that is why it remains constant, because you know that you are giving the velocity, but that type of velocity remains, that is known as horizontal motion, because I am discussing about horizontal motion. In case of horizontal motion, this component remains constant throughout this journey, because just see it from this point to this point. This is called the range. It is moving in this direction, in horizontal direction. So this component, horizontal component of the velocity, because there are 2 components. This one component, because u is this, and this is, suppose this one is angle theta, and here is u cos theta, and here is u sin theta. U sin theta actually helps us to move in the upward direction, but after all, you know that it will reach at a particular point, peak point, and after that it will come back. But in horizontal direction, this component, this is known as this horizontal component, this will remain constant, this will remain same throughout this journey. Now we are discussing about vertical motion. Vertical motion, so we are very close to the correct option. Either C is correct or D is correct. But now we are discussing about vertical motion. Vertical motion means, you know that the ball is moving in the upward direction. Is it clear? The vertical velocity changes at a constant rate. Why it changes at constant rate? Do you know? Because there is only one force, that's weight, in the downward direction. It slows down. Finally, when it will reach it at the top point, at this point, when the ball reaches at this point, it will slow down. It takes some rest for an instant of time, and then it will come back again. So we can say in the vertical motion, this acceleration is constant because it's a constant rate, because it's slowing down. And then hits at the zero velocity, at the peak. So we can say that there is a constant acceleration downwards. Then again, there is constant acceleration downwards. So we can say there is constant acceleration downwards. This happens with the projectile. Just see this one option, that is the D option. Acceleration decreases upwards, then increases downwards. No, acceleration remains constant. What is the meaning of acceleration? Change of velocity with time. That remains constant. He says in D option, acceleration decreases. No. So the correct option is C. Because there are two types of motions, vertical motion and horizontal motion. Okay, I hope you understand it very well. Now there is another question. An aircraft flies from London to Sydney in a time of 21 hours, 40 minutes, the distance traveled. What is the distance? First of all, we will discuss about distance. Distance is 17,000 kilometers. 17,000, we can convert it meter. So we will multiply 1,000. Once we will multiply it by 1,000, it will come out 1.7 into 10 raised to the power 3 zeros, 3 zeros, 6 zeros, and then we are putting the point in between 1 and 7, so it becomes 10 raised to the power 7. So the distance is converted into meter. Now there is time. Time is 21 hours plus 40 minutes. 21 hours is 21 multiplied by 3600. You know that 3600 seconds is actually in 1 hour. Plus there is 4 minutes. 4 minutes converted into seconds. So 4 multiplied by 60. So this is, as we are calculating it, it is equal to 7,800 seconds. You can calculate it. It's exactly equal to this. Now the point is, what is the average speed? Speed is equal to distance divided by time. Distance is 7,800 divided by time. So distance is actually equal to this one, 1.7 multiplied by 10 raised to the power 7 divided by 7,800. This is meters and this is in second. So if we were to calculate it, it will come out 2.2 multiple 10 raised to the power 2 meter per second. Because there is less space, so I am calculating and directly write the answer. 2.2 multiplied by 10 raised to the power 2. Now you check, there are 4 options. Which option is correct? First one option is 2.2 meter per second. No, there is 10 raised to the power 2. So no, this one is not correct. 2.2 multiplied by 10 raised to the power 7 micrometer per second. I will convert this. This is, we will check B option first, then C, and then D. 2.2 multiple 10 raised to the power 7. Micro means 10 raised to the power minus 6. So it is 2.2 multiplied 10 raised to the power 1 meter per second. No, this is not correct. C option I will check. I will check the C option. 2.2 multiple 10 raised to the power 11 micro nano. There is nano 10 raised to the power minus 9. This is 2.2 multiplied 10 raised to the power 11 minus 9. That is 2. That is equal to meter per second. So the correct option is, which is the correct option? C option is the correct. This is the correct option. I hope you understand it very well. Now there is another question, that is, a golf club hits a golf ball. The graph shows how the force F on a ball varies with time t. This is the graph, force versus time. You know that according to Newton's second law, F is equal to ma. So F is equal to m. Can we write velocity as this acceleration is equal to velocity divided by time. So this is force versus velocity divided by time. So he is taking the velocity time graph. All the four options are velocity time graph. Just see now, velocity time, velocity time, velocity time, velocity time. Which option is correct? Just see here. In the first half of this graph, there is increasing quantity. This one is increasing. You understand it very well? I hope you understand it very well, because in the first half, the graph is increasing. So can we say in first half, force is increasing? Force increases. Then acceleration is also increasing. Acceleration increases. Then can you tell me where is velocity and time graph that is slightly increasing? This one is first option. This graph is starting to increase, but it is curved to downward. That means it's decreasing. This one in the first half it is increasing. Correctly, it is increasing. Next one point is in this part there is decreasing force. This steep is increasing. This one steep is increasing. This steep is increasing up to this. In the second half, there is a force. In the second half, force is decreasing. In the second half, force is decreasing. Force decreases, but still positive. Because the graph is not going in the downward direction. No. It does not cut this time axis and then go like this. I'm telling you this so that you will understand better. It will not go like this. If it will go in the downward direction, then it is negative. But up to this position, this is positive. But force is decreasing. Can we say at this time acceleration is decreasing? Acceleration decreases. Acceleration decreases. But the ball is still steeping up. Ball is still steeping up. Steeping up. So it is this one part. Here, if I will check this one graph, here it is increasing. But here is now decreasing. This one part is actually increase. This one part is decrease. So the correct option is B. Correct option is B. You understand it very well? I hope you understand it. Now there is another question, that is 10th question. What is meant by the mass and by the weight of an object on the earth? You know, it is very easy question. Mass is related with inertia. What is inertia property? You know that is an inherent property of a body. If the mass is more, inertia is more. The property that resists its acceleration. No momentum divided by velocity, no. Gravitational force, no. Pull of the earth, no. The property that resists its acceleration, just check it. If there is a person that's having maybe 90 kg weight, he is resisted to move. He is not able to move. He is not quickly move. But if there is another person that's having less weight, there is less inertia. There is less inertia. So this one, D, according to mass, is correct. But what is weight? Weight is a pull of the earth. So D is the correct option. This is very easy question. Now I will go towards the 11th question. A thin horizontal plate of area 0.036 meter square is beneath the surface of a liquid of density 930 kg meter per cube. The force on one side of a plate due to the pressure of the liquid is this thing. You know there are two formulas of pressure. Pressure is equal to force divided by area. And there is another for liquid, pressure is equal to rho g h. Density multiplied by acceleration due to gravity and height. First of all, we will find what is pressure. Pressure is equal to force. Force is 290 Newton. Divided by area is 0.036 meter square. If we are calculating this, it will come out 8055.56 Pascal. You know what is the unit of pressure, that is 80, this is Pascal. Now we are actually finding what is the depth. Depth means this one, h. How to find h? H is equal to P divided by rho g. Pressure is 8055.56 divided by Rho is actually the density, that is 930, multiplied by G, that is 9.8. If there will be given 10, then you can take 10. If we are calculating it, it will come out approximately 0.88 meter. So the correct option is A option. Understand it? Now there is another question 12. Sphere X and Y form an isolated system. There is an isolated system. Mass of Y is greater than mass of Y is greater than X. Okay. Sphere Y is initially at rest. This is sphere Y. It is initially at rest. Now sphere X collides elastically with sphere Y. Now there is X sphere and it is in motion. The speed of X before collision is U. Its speed is U. Before collision. Which statement is correct? Once it will hit this sphere Y, Y will come in the motion. So we can see sphere X rebounds with a speed that is greater than U. No. How it is possible it is greater than U? No. Sphere X rebounds with a speed less than U. Maybe we are thinking about this. And sphere Y moves off with a speed that is also less than U. Maybe possible. But see, I will check what is written here. Sphere X rebounds with the speed U. Rebounds with the same speed. No. Sphere Y remains stationary. How it is possible to remain stationary? Sphere X remains stationary. How it is possible? So there is only one option, that is B. Sphere X rebounds with a speed less than U. Yes. Sphere X, once it will hit this sphere, it will rebound but with a speed that is less than U. Initially it was with U. If it has 20 meter per second speed, then it will not have 20 meter per second. It will have 10 meter per second or less than 20. And sphere Y moves off with speed that is also less than U. Why? Because Y is greater than. Maybe its speed will be more, but it is mass is more. Mass is more. So it will move, but little bit. It will not move too much as the velocity of X have initially, before colliding. I hope you understand it. Now there is 13th question. A ball of mass 0. Mass is given. Okay, mass is 0.10 kg. Is thrown towards a stationary vertical bat. The bat hits the bat. The ball hits the bat with a horizontal velocity of 20 meter per second. This is a horizontal velocity 20 meter per second. That is initial velocity is 20 meter per second. But the ball rebounds and leaves bat horizontal. That means V is equal to 15 meter per second. So initial velocity is given. Final velocity is given. So we are finding the change of momentum. You know that change of momentum is equal to mass final velocity, mass initial velocity. So we can take mass as common, V minus U. Mass is how much? 0.10. And what is V? V is final velocity, but final velocity is 15 meter per second, and that will be in another direction. So this is positive, this one is negative. You know velocity is a vector quantity and direction plays very important role. So negative, this is minus 15 and this one is minus 20. So how much is this? This is equal to 0.10 multiplied by, I think, 35. So this is equal to 3.5, that is in minus. But there are units Newton second, Newton second, Newton second. You understand it? This is mass into velocity, that is kg meter per second. We can just multiple here second and here second. If we check now, this is minus 3.5 kg meter. Here is second. This per second we will take here. This per second. Remember, this per second. Just see. This is meter per second. Actual unit, kg meter per second. I will write here second and second. It will become kg meter second square. And here remain a second. This part of unit is equal to how much? That is Newton second. You know that F is equal to MA and M is kg. This is meter per second square. So kg meter per second square is actually Newton. Kg meter per second square is Newton. I hope 3.5 Newton second is the correct option. This is the correct option. Now we are going towards 14th question. Very easy. An isolated object of negligible weight is acted on by two coplanar forces of the same magnitude, in which diagram is the object equilibrium. I think there is a momentum. There will be momentum, there will be, and this is the correct option. Yes. Why? Because both forces are opposite to each other and they are along the same line of action. Yani same line of action. Same line of action. Remember here, when there are two forces exerted at an object along the same line of action, that is F1, F2, and both are having same magnitude, F1 is equal to F2, this object will be at rest. Object remains at rest. Remain stationary. I hope you understand it very well. Now there is 15th question. So we will complete this video, and after that I will make another video to explain other questions. A uniform beam PQ rests horizontally on a support of S. This is the support S, you know. A rope is attached at one end of the beam. The rope is at an angle of 60 degrees to the vertical and exerts a force F in Newton on this. You know, this force is actually acted at an inclined plane, so it is definitely resolved into two components. This will be F cos theta, that is 60 degree, and this will be F sin 60 degree. Now you know moment is that is known as torque also. That is always equal to force multiplied by perpendicular distance. And he says about S, this is about S, and what is the distance remaining from S to this? This will be 2.5 minus 0.30. That is force. Which component is the force now? This is the force exerted in the vertical direction. You know that momentum is, this is the distance and this one is the perpendicular force. This is perpendicular distance and this is force. Force is which component? F cos 60 degree. Multiplied by distance, this is the perpendicular distance here from this to this, that is 2.5 minus 0.30. 2.5 minus 0.30. How much is this? 0, 2, 2.2. This is 2.2. And this is F. What is F cos theta? I think this is 0.5 multiplied by 2.2. That is equal to, if we multiply 0.5 multiplied by 2.2, that is equal to how much? Can you tell me? Can you tell me what is the force now? That is 1.1, and F remains as it is because there is not given any magnitude. It remains as it is. 1.1 F. This is the correct option. I hope you understand it very well. All the questions. Thank you to all of you, and we will meet in the next video. Okay, bye. Thank you.